Hardware issues in Linux. Hardware is underlying everything that we do on the computer. Hard disks, network cards, main memory, and peripherals work continuously without very much direct intervention from the user. In this video, we'll talk about adding and configuring new hardware for your Linux system, and we'll also talk about kernel modules and the role that they play in adding and configuring hardware for your system. So let's get started. Let's start with a discussion of hardware drivers and where they are in your system and where you can get new ones if you have some new piece of hardware that you want to install in your Linux system. The first place is actually in the Linux kernel. A lot of hardware drivers are already in the Linux kernel. Either they're there compiled directly into the kernel for the most common hardware devices, or they're add-ons to the kernel via kernel modules. And we'll talk about kernel modules in a few minutes here. And another place to get drivers is actually from the manufacturer of the hardware device themselves. A lot of hardware manufacturers these days are distributing Linux device drivers with their products because they know Linux is growing in popularity and they don't want to alienate themselves from a segment of the market. Okay, so they're actually distributing Linux device drivers with their products. And there's a bunch of special development projects out there. A couple of them that I want to note, it's not that the hardware is all that special, it's just that it's been notoriously difficult to hook up to Linux systems in the past. And Scanners is right at the top of that list. If you go to mostang.com/sane, you'll read about the SANE project. And SANE just stands for Scanner Access Now Easy. Okay, you gotta love the acronym. And the SANE project is just working, they're devoted to scanners. And like I said, scanners have been a notoriously difficult thing to hook up to your Linux machine. And so if you've got a scanner, you have to check out SANE to get it up and running a lot easier than in the past. And then USB devices are another specialized sort of hardware device. All sorts of things can be USB devices these days. Keyboards, mouse, graphics tablets, zip disks, all sorts of things can be USB devices these days. And USB has really gained in popularity for a lot of reasons. It's a fast connection. USB devices are also hot swappable, which means you can unplug a USB device from your computer, you can plug a different one in, and everything will just work fine. You don't have to like reboot your computer just to get it to recognize that new piece of hardware you plugged in, like you have to with other sorts of ports on your computer. USB ports are special that way. And you can find all about find out all about the Linux USB project at linux-usb.org. And this will have all sorts of information about various USB devices and hooking them up to your Linux system. To add hardware to your computer, the first step that you have to take is to physically connect the hardware to your computer. All right, this might seem obvious enough, but there's a lot of details to deal with this. Let's talk about some of those details and we'll come back to this slide later. So to physically connect the device, there's basically three kinds of devices that you're going to connect to your computer. One is an external device, something that's completely external to the computer. It's outside of the case altogether. All right, it probably plugs into the back of the computer, maybe it also plugs into the wall for power, and once you do that, then you're good to go. If I show you the picture of a back of a PC, an external device is going to plug into one of these slots back here and possibly also plug into the wall for power, and then you'll be good to go. When you install an external device, the computer should probably be shut down. You install the external device, and then you boot it up, and then the external device will be recognized when the system boots up. Okay, so that's the basics of installing external devices. They'll be very simple. And then internal devices and expansion cards, you do have to go inside the case of the computer to install these. And so they're a little bit trickier because you're dealing with sensitive electronics in there, so you have to know what you're doing. Sometimes if you've never done this before, it seems kind of intimidating, but it's actually pretty simple to install internal devices and expansion cards. Let me show you the picture of a motherboard, and that'll make this process a little bit easier for you. So here's a basic motherboard. Your motherboard might look a little bit differently. The things might be arranged a little bit different. They could be horizontal instead of vertical, or vertical instead of horizontal, and they might just be laid out differently. But you can tell by the shape of things what they are. These long, skinny things here are ISA slots. Okay, these right here are PCI slots. These two things right here are slots for IDE disk drives. This slot right here is for a floppy disk drive. These slots down here are for memory cards. Okay, and basically anything that you're going to deal with plugging into your computer is probably going to plug into one of these slots that I just showed you. All right, and when you're in here, you have to be careful of two things. Once, anytime you're in here, you have to make sure the power's off to your computer. It should be shut down, the power should be off. I'd even unplug it from the wall just as an extra level of safety. And then this right here is where the power is going to be given to the motherboard. It's going to come in through there. And basically anything that's connected to here, don't touch. Look for where the main wires for this go, and it's going to be connected to the power supply for the computer. Don't touch that. Don't touch anything that's connected to that power supply. not. That's how you'll prevent yourself from being shocked and potentially being hurt. Okay, so don't touch any of that stuff. The other thing you have to worry about when you're inside the computer touching any of this sensitive electrical stuff is that you don't shock it. All right, just like little charges that you build up from shuffling your feet across a carpeted floor actually could end up shocking one of these boards and damaging one of those boards. So anytime you work on one of these boards in here, installing a new board or removing some old board or whatever, any work that you do inside of there, you should be wearing one of these wrist straps. It's called an ESD wrist strap, and ESD just stands for electrostatic discharge. Now this wrist strap, this goes around your wrist obviously enough, and then this wire connects, I think this is an alligator clip right here, and you should just connect that to something big in metal if you have an alligator clip. Some of the wrist straps have like a little plug on it that would go into the negative or the ground plug of like a 3-prong outlet. So if you have that 3-prong outlet where it's like this and then that, some of them have a plug on there that plugs into the round part up top that's like the ground. Okay, so whatever your wrist strap has, make sure it's grounded. Attach it to some big metal desk if you have a metal desk, and make sure like the paint's scraped off if you've got one of these alligator clips, so that you have a good connection so that you're well grounded. And then any static charge that you've built up is discharged through this wrist strap to that big metal desk that won't even feel the charge, as opposed to some card in your computer that would really feel that charge. Even though it's a really small charge, these things are very sensitive electronic equipment, and they could be damaged by just the smallest shock. Okay, so make sure you're always wearing a wrist strap when you're dealing with that stuff. Now what I want to do is show you some cards plugged into this motherboard. And what the first picture I'm going to show you is 2 network interface cards plugged into this motherboard. One's going to be plugged into this top ISA slot, and one's going to be plugged into this top PCI slot. All right. Now, the picture is going to be from a slightly different angle, but you should be able to recognize that it's the exact same motherboard here. So here's the 2 network interface cards plugged into the motherboard. And you can see this one's plugged into the PCI slot, this one's plugged into the ISA slot. And then this face right here on both of these cards is going to be on the back of your computer. This is going to be accessible by just plugging something into the back of the computer. This jack right here is called an RJ45 jack. It looks like a telephone jack, but it's a little bit fatter, a little bit wider, a little bit thicker, whatever you want to say, and it's just got more pins in it. And this jack, this RJ45 jack, that's like what you'd hook up to go onto the Ethernet or something. Okay, so that's the 2 network interface cards plugged into here with that RJ45 jack accessible. When this motherboard goes back into the computer, right now it's obviously out of the computer, when it goes back in, there'll be like little screws where you can attach these things to the case so that they don't wobble around. You don't want them to be able to shake or be moved when somebody plugs something in. You want them to stay solid because you don't want to damage this slot down here that they're plugged into. Okay, now the next picture that I show you will be a hard disk plugged into one of these IDE slots. Okay, now that is going to look a little bit different because the hard disk has this ribbon cable that attaches it to here. Okay, the network interface cards plug directly into the slots. They didn't have any ribbons, they just plugged right in there. The hard disk is going to sit a little distance away from the motherboard, and so it's got this ribbon cable to attach it to the motherboard. Now this is a 40-pin ribbon cable. All right, and that 40-pin ribbon cable, on this side of it right here, if you look carefully, it's got a red stripe on it. If the ribbon cable was right in front of you, that would stand out clear as day. It just doesn't stand out so much in this picture. But that red stripe is very significant for determining which way to plug this ribbon cable into the slot on the motherboard. The red stripe signifies the pin 1 end of this 40-pin cable. All right, and the pin 1 end of the 40-pin cable, there's also a marking on the actual slot itself that shows where to plug that in, what pin 1 end should be, and then you can plug it in correctly. If that red stripe wasn't there, you wouldn't know which way to plug this thing in because you can actually flip it around 180 degrees and still plug it in. The disk won't operate correctly, but you wouldn't know that. So that's why that red stripe is there to tell you which side is the correct side to plug in. All right, so that's the basics of connecting, physically connecting hardware. Now let's look at some of those other issues. So once you've physically connected the device to your computer, the next step I have listed here is to set jumpers on the card or the device. Now perhaps this is outdated and I'm showing my age. Perhaps I'd rather think of it as showing my experience. Okay, so the jumpers, I've typically seen these on older ISA cards. So if you're installing an older ISA card into your computer, you might see one of these things. And there's jumpers in other places on your computer as well, like on your motherboard. If you want to overclock your processor, typically you hook up a jumper to do that. Now what a jumper is it's basically there's these pins on like the older ISA cards like I was talking about. And then a jumper is this piece of metal that's got some grooves cut into it, some holes cut into it, and you slide this jumper down over a couple of these pins. And basically when you slide that down, since it's made of metal, it forms this connection and it creates this circuit. And when you create this circuit between these two pins, you're altering the behavior of that card or that device or that motherboard circuit or whatever. Okay, and you know, the only way you'd know to hook stuff up is you have to look at some manual. Look at the manual for the card or the motherboard to see what the action's going to be when you put a jumper over like these two pins or those two pins or those two pins and so on. And then you can, you know, if you want to alter the behavior in some way, you can hook up that jumper. Now, like I said, that's probably a little outdated. Any new PCI card doesn't have these. Even newer ISA cards, I haven't really seen them on those, just on older ISA cards. And nowadays and in the future, you're typically going to alter the behavior of some device through drivers. So you're gonna load and configure the drivers, and in that configuration process is how you're going to alter the behavior of the device, just like you would have in the old days with jumpers. Okay. Now these drivers, they can be in the kernel directly, and they can be compiled into the kernel. And if you're going to add a driver directly to the kernel, you're going to have to recompile the kernel to do that. And that's that's no place for a novice user. Even an intermediate user should be really careful when you're recompiling the kernel to do something. Okay. So another option that Linux has, instead of having drivers located directly in the kernel, is it has what's called kernel modules. Now these modules are like drivers that are loaded on demand. So when some device gets accessed, if the drivers for that device are not in the actual kernel itself, and they're in some module, then when that device gets accessed, that module will be loaded then, and then you'll be able to access that device. Okay. Now the kernel modules are controlled by some files. One of those files is the modules.conf file. On some systems it's called conf.modules. Okay, now this file basically it has a format in it that says for the various devices on your system, you know, what drivers do they need to operate. Okay, so that's the information that's in modules.conf, is for each device, you know, what drivers need to be loaded for that to work. Okay, and so that's what's going to happen. They're going to be loaded on demand. Now there's some commands that operate on modules. insmod for install module or insert module. Mod probe, which does an insert, but it does a much more sophisticated sort of insert. We'll talk about that in a second. And lsmod to list information about modules already installed on your system. Okay, so for the insmod command, there's some various options you can use to install modules on your system. There's the -F option, and what this does is force installation. So a lot of times these modules you're installing, these drivers, are like binary executable files in some sense. And they've been compiled for some kernel and some architecture. And maybe the kernel version they were compiled on is different than the one you're running. But you should be able to do it. If it's not too far off, you should be able to do it with the -F option and just force the installation, and then that module will then be loaded, and it will be in the list of modules that are active on your system. Okay, and then there's the -K option. Now the -K option sets an auto clean flag. So what that says is once the module is inserted, it'll be working and everything will be fine. But once it's inactive for some period of time, then the -K option says to remove that module from the system. And the reason Linux deals with kernel modules as opposed to having every single driver inside the kernel itself is it just saves memory. That way the kernel's not all big and unwieldy and takes up a lot of memory on your system. It's nice and small and streamlined, and then when some device gets accessed, we load that module in, we do our work, and then when that device is done being accessed, we take the module out. Again, just to make everything more streamlined. And this -K option says that after the module has fallen out of use, once that device is not being accessed, you can take the module out of the system. Okay, another useful command or an option for the insmod command is -P. I love these options because it just like does a test run. It doesn't actually load the module, just does a test to let you know what would happen. And I like commands like that, especially when you're dealing with stuff having to do with the kernel. You don't want to screw anything up there. Okay, so there's the insmod command. Now, the drawback with insmod is that it just inserts one module. Just like when we were installing software way back when, we talked about, you know, dependencies in software. okay? And when you went to install some piece of software, it depended on some library, you had to install that library. Maybe it installed on some, it depended on some other program, and you had to install that program, which depended on other libraries, and it just became this whole tedious process. Well, that's what modprobe is for. Modprobe is basically deals with all those dependencies. Now, there's another file up there called modules.dep, which stands for modules.dependency. Okay, and basically this file has a lot of information about what modules depend on other modules. So when you go to insert a module with modprobe, it's going to look at the dependency file and determine what other modules must be loaded for this one to work correctly. Okay, so same kind of thing as insmod. The -k option inserts it with the auto clean option on. Basically, it's the same kind of thing here. And like I said, it just looks at the module dependency information when it does the loading. So it might actually load many more than just one module if that's what it takes to get the things working. Okay, and then there's lsmod, and basically it's just if you want to know what modules are loaded at at any moment in the system, you can determine that with the lsmod command. Okay, and it'll tell you the module and the size and what its use is and that kind of stuff. Okay, so that's information about kernel modules, and then going back here, let's talk a little bit about making the device accessible to the users. Actually, before we talk about how to make hardware accessible to the users of your system, I just want to talk more about modules, and I want to do it on the Linux screen so I can show you some stuff firsthand that we've been talking about on the whiteboard. The first thing I want to do is show you the modules.conf file. And you can see I'm in the /etc directory, so that's where modules.conf is. So modules.conf's there. The format's pretty easy to understand. If you did a man page on modules.conf, you would see actually there's a lot more directives and options for how to set up modules.conf, and it could be quite complicated. But typically it's pretty easy, and this one's no exception. So here the format is, for most of these lines, is that it says alias, and then it has two fields after the alias. Now what this is saying, take this one for instance, this one is saying the first field is the hardware, and the hardware it's talking about is Ethernet 0, or the Ethernet card. And then the next field is the device, or the driver, or the module that needs to be loaded for that hardware device. Alright, so this is saying the PCNet32 module must be loaded so I can access my Ethernet card. And the SCSI host adapter, in order to access that, I need to have the bus logic module loaded. Alright, now this one down here is a little bit special. The SB module is being loaded. And what makes this special is that it also has an options line associated with it. So when the SB module is being loaded, then all these options or arguments or parameters, whatever you want to call them, are being set. And they're being sent to the module so that when the module starts up, all these options are then being set to these values. Now, if you're going to set options with a module, you need to consult the module's documentation. There's no possible way that I could generalize about all the different modules and the settings that you want to use. And also, just the names of the parameters change. Even if they're setting the same thing from one module to another, sometimes the name of the parameter changes. So you need to consult the module's documentation in order to set options for a module. Now let me do the lsmod command, and this lists all the modules on my system. And you can see the various modules here. There's the PCNet32 module, there's the bus logic module, here's a module for a CD-ROM player. And you can see this module's got the auto clean feature set. And that's that feature that means that it will be unloaded off the system if it's inactive for some period of time. And the way Red Hat deals with that is it has a cron job. Remember when we were talking about cron jobs, that's the utility for regularly scheduling things at some regular interval. And Red Hat has this cron job that runs every 10 minutes, and if some module is unused in that 10-minute cycle, then it's loaded off the system. Alright, and it's not removed or anything, it's just made inactive. And then when I go to access the CD again, if it was inactive and unloaded, then I go to access the CD again, then it will be loaded back in for that time. Alright, so that's the way modules work. They don't take up unnecessary amounts of memory for sort of like non-critical devices like a CD player. Now things like a PCNet, this is controlling my Ethernet card, and bus logic is controlling my SCSI host adapter. So those are more important, right? Controlling the Ethernet card and SCSI disks and things like that, these are more important features. They do not have auto clean set. And the reason they don't have auto clean set is because the trade-off is weighted the other way now. It's better to just have that thing in memory all the time, so it takes up some memory, fine, but the access to those devices is now going to be faster. Every time I access my SCSI disk. I don't want to have to load some module out of memory. All right, so that's the basic rundown there of why things have auto clean and why some things don't. Now, another thing I want to do before we go back to the whiteboard is just to show you when you do an insert mod or a mod probe, when you do those commands, where do those modules come from? Where are they being inserted from? And I want to show you that now. So the first part of the directory path that they're being inserted from is /lib or /lib/modules. So I'll hit enter there and do a listing, and now you can see the kernel version number. This is just a directory of modules. If you had ever installed multiple different kernel versions on this computer, then there would be multiple directories here for the older kernel versions and so on. You just want to go into the one that you're running right now. And for me, that choice is easy because there's only one in here. So I go in there and I do a listing, and now you can see the modules.dep file for the modules dependencies that we were talking about earlier that I didn't tell you where that was before. It's in this lib/modules/kernel version number. There's modules.dep. And then there's this directory in there called kernel. All right, if we go into kernel, you'll see in there that there's more directories, and these are just classifications of different modules for the kernel. The net ones are for networking modules. FS are for file system oriented modules. All right, so they're just classified in these different organizations, and when you go to insert a module with insmod or mod probe, this is where they're coming from. To make a device accessible to the users of your system, it's actually pretty easy. The first thing that you have to know about is the /dev directory. Now the /dev directory holds one entry for every device on your system. And it actually holds one entry for every device you might ever add to your system. That might seem like a tall claim, but when we go back out to the Linux screen, we'll do an ls on the /dev directory, and you'll see hundreds and hundreds, if not 1,000 and some files in that directory. And then what it is there's files in this directory, and the files all refer to some device or some partition on some device or something like that. And the way that you control access to that device is you just change permissions on this file. So this file is like a file like any other file we've seen. It's got read and write permissions. It's got an owner, it's got a group, and so on. And if I change permissions on this file, that's going to change permissions on the device that it's referring to. Now, I've listed some here like FDX, like FD0, FD1, FD2, and that's for the floppy disks on your system. The devices in there that start with HD refer to IDE hard disks. So HDA refers to the first one, HDB refers to the second one, HDA1 refers to the first partition on the first disk, and so on. Okay, and we've seen that before. I just wanted to refresh your memory. And then the devices that start with SD are for SCSI disks. The X and the Y mean the same thing as on the IDE disks. And then there's a whole subdirectory of the /dev directory for USB devices. So /dev/USB/whatever, all the devices in there are USB devices. Okay? And like I said, you just change the permissions on this file, and that's going to change the permissions on the device. What I want to do now is go back out to the Linux screen, and let's poke around the /dev directory a little bit more. So let's go over to the /dev directory. Okay, and we'll do an ls, and I'll just hit enter here and let it run up the screen just so you can see how many files are coming up. I mean, it's like 7 columns wide, and it was many pages long. So there's just tons and tons of files in here. I want to do a long listing on one of these files, FD0. Let's do the listing on the floppy disk. Floppy drive. So this floppy drive, you can see here, is owned by Perry. And that's just because this is the way Red Hat deals with it. That's because I logged in as Perry to this computer, and so now, even though I'm the root user, I've switched over to be the root user. Because I logged in as Perry, it gave Perry access or ownership of the FD0 floppy drive. All right? And the reason it did that is because certain operations that you do on a floppy drive, like if you're going to format a disk on a floppy drive, you need ownership of the drive to do that. And that's why Red Hat gives you that permission. Now, other distributions of Linux don't do that, and they leave it up to the system administrator to deal with this. Now, the system administrator could deal with it any number of ways. The system administrator could just give the person ownership of the device, and then they'll be able to format disks on the floppy drive. Or there's this group here called floppy. The system administrator could put people into the floppy group that need to do like format floppy disks, things like that. Okay, so just like when we used groups to share files in directories in our home directory and stuff, we can use groups so that multiple people, certain people that we determine can access this device directly, like to format a disk or something. Now, a lot of devices like SCSI disks and things like that, we don't ever need to give like ownership of that device. And actually, it would probably be a mistake to give a person ownership of the SCSI device, because then they could access it directly and do things, and if they did something incorrectly, maybe the system won't boot anymore. All right, so things like SCSI disks, we should just use the mechanisms and the drivers that are in place to do the access, the reads and writes from that disk, and we don't need direct ownership to do like normal operations on SCSI disks. All right, and another thing is like Ethernet cards. Ethernet cards are not in, they don't have an entry in the /dev directory. And it's not because they're not supported, it's just because there is never an instance when you need to give direct ownership to somebody for an Ethernet card. Every access to the Ethernet card should be done through the mechanisms and the protocols that we've talked about before, and nobody should ever have direct access to that Ethernet card. All right, so that's like a rundown of the /dev directory, and that pretty much wraps up this video. We'll just do a little wrap up on the whiteboard now. It's time to wrap up our first video on hardware issues. The first thing we talked about was adding hardware to your computer. We talked about physically hooking it up. And just remember that anytime you have to go inside the actual case of the computer and touch something on the motherboard, make sure you're grounded with one of those wrist straps, and make sure you don't touch any power supplies or anything and shock yourself. And then we talked about drivers and modules and kernel modules and how they work, and how you can insert them and remove them from your system. And finally, we just talked about the /dev directory. Well, I hope you found this nugget informative, and thanks for viewing.